Hi, everyone. I'm Georgia. I'm the CEO and founder of Reclamation Factory, and I'm here to tell you about how we're reclaiming your plastic by listening. Every year in Michigan, we throw out 1.5 million tons of municipal plastic waste, and yet, in the United States, we currently import recycled plastic from other countries to meet domestic manufacturing demand. So, if that waste is so valuable, why are we putting it in a landfill? Well, in order to recycle plastic, you have to sort it. And the more you sort it, the more valuable it is. And by contrast, the more contamination it is, the less likely it is to be made into something new. But sorting can get costly and complicated really fast. There's costs and international regulations that are complicating this process, but I want to talk about these technical challenges. The state of the art, which is near-IR spectroscopy and visual AI, is very expensive, and it really requires these large economies of scale to be cost-effective. And there's also a lot of types of waste that near-IR and visual AI simply cannot see. I'm talking about black and highly pigmented waste, crushed and shredded waste, compounded and filled waste, and our fastest growing and most valuable waste streams, that's e-waste and auto waste, look just like this. So instead of reclaiming this valuable material, recyclers are paying to put it in a landfill. The Reclamation Factory has a solution. We have invented and patented a brand new method of classifying and sorting plastics using an untouched sensing modality, audio. We are using low-cost sensors and high-tech AI to make plastics recycling profitable. All right, and here's how we do it. Every plastic resin emits a characteristic acoustic signal that we can use to sort that plastic without the technical limitations of other technologies and at a really wide variety of scales. Every material emits a characteristic acoustic signal. Acoustics are really highly related to the molecular structure of a material. That means you can't always see what something is made of, but you can always hear what it's made of. And this works on real material streams. This is actual plastic that we took off of a last chance line from a materials recovery facility in Ohio. So this is plastic that went through 4 near-IR sensors and was still landfill bound. And you can see that we were able to sort the highest volume and most valuable plastic, polypropylene, to 100% precision on our first try. Plastics recycling is a large and growing market in North America, and acoustic AI can tackle a lot of material streams, but we're really focusing in on these hard-to-recycle but high-value material streams. We see our 7-year obtainable market as $100 million recurring revenue in North America alone. And our business model is a feedback loop that benefits both us and our customers. The more sensing suites we launch, the more data we collect, the more generalized our AI can be, and that allows us to move into new materials and into new markets. And I really want to highlight that this is a first-of-its-kind acoustic data set that we see as its own product as well. And it benefits both us and our customers. This is a revenue model from a client of ours in Pennsylvania. We found that with 2 acoustic AI units, we could recycle all of their e-waste black plastic. For them, we're reducing their landfilling costs, we're increasing their secondary market revenue, and they would see an ROI of less than 1 year, and we see a nice, healthy recurring revenue. Let's translate that into climate impact. In the state of Michigan, all of those hard-to-recycle plastics, acoustic AI recovered all of those hard-to-recycle plastics. That would look like diverting 1,000 tons of plastic every single day, and that's equivalent to nearly 1 million tons of carbon offsets every year. That would bring the state of Michigan about halfway towards their goal of diverting 45% of plastic waste. Our biggest competitor is actually landfilling, but that process gets more expensive every year, and additional laws and regulations really complicate that. Right now, we have a couple of ongoing pilots, and our goal for the year is to prototype an industrialized and scaled version of our system for in-situ testing. We're also currently raising a pre-seed round to help us with that build, and also to help us grow our team. And speaking of team, I am a robotics engineer, and I have multiple experiences as a founding member of high-tech startups. And we're lucky to have Thomas and Akshay with us. And what we're looking for today is we're looking for pilot partners in the state of Michigan to help us grow our product with them. We want to train our AI around your problem. Thank you so much for your time, everyone.